The goal of the exercise is modeling a concept preliminary hull shape immediately employable for further design work using Orca 3D V3 plugin for Rhino 3D V8. Open Rhino, create a new file using the large object meters template. Here are the target values of the hydrostatic parameters. Now we will set some Rhino and Orca parameters. From the Tools pull-down menu, open Options. In Units panel, set absolute tolerance to 1 mm, leave angle tolerance to 1 degree, and display precision we will set also to 1 mm. Model units are already set to meters as we have used large objects meters template. Click OK. From the Orca 3D pull-down menu, open Properties. Change current units to C-tone. Set model orientation forward to positive X and up to positive Z. In the Hydrostatic tab, leave fluid type as seawater and keep the rest parameters with default values. Click OK. From the Orca 3D pull-down menu, open Hull Design, Hull Assistant. There are 5 types of hulls which can be designed with Hull Assistant. For the dry cargo vessel, we will choose Ship Assistant. Open Assistant. Change the description to dry cargo ship 113 meters length overall. There are 4 tabs in the Ship Hull Assistant window: Dimensions, Hull Form, Bow Transom, and Bow Bulb. We will start with the main dimensions of the hull. Set length on deck to 113 meters, beam on deck to 15.2, depth at bow to 985, and depth at transom also to 985. Set draft to 7.1 and transom height at about baseline to 6.2. During the design process, we would like to see the current stage of the shape and changes we produce by changing the different parameters. Check the Preview Hull checkbox. We would also like to see the sections. If necessary, custom sections can be defined. We can also get a live preview of 4 selected hydrostatic parameters at a time. You can choose parameters from a list of available parameters. We'll choose block coefficient, water plane coefficient, displacement, and vertical position of center of buoyancy. By default, UCS origin is located at the intersection of centerline, draft waterline, and forward perpendicular. We would like to change it so that it will be located at 2.75 from transom and at the baseline level. To achieve this, we need to shift the hull in two directions. We need to shift it 110.25 meters forward, and we need to shift it 7.5 meter up. Notice how the shape and hydrostatic parameters are changed. If we change the transom heights, you will see that shape is changed and hydrostatic parameters are changed as well, though they're still far from the desired values. We will proceed with the setting up bow transom parameters. Switch to the bow transom tab. Stem rake defines the angle between the stem and vertical direction. We will set it to 37 degrees. Stem curvature parameter allows to define the straight, concave or convex stem. We will set it to 0 to have a straight stem. Bow rounding is responsible for the fullness of the water lines at the bow. We will set bow rounding to 0.21. 4-foot shape allows to change the rounding between the keel and stem. We will set this parameter to 0.68. Transom rake defines the slope of the transom. We will set transom to vertical position. Transom deck width. We will make the deck width at the transom slightly smaller than the molded beam, and we will set it to 0.95. Keel rise point parameter allow to control the aft ship shape run from bottom to transom. We will set keel rise point to 0.7, well 0 to 0.31, and well 1 to 0.19. Now we will switch to the hull form tab. Maximum area location will be located near the midship frame. So we will set the max area location parameter to 0.15. 52. From the current status of hydrostatic parameters, we see that we need more volume below the waterline. We can achieve this with longitudinal prismatic control parameter. We will set it to 0.75. Shape, fullness of the aft, middle and forward frames can be also controlled by the section tightness. We will set forward tightness to 0.8, midship to 0.25 and aftship to 1. Dead rise controls the bottom slope at the aft, midship and foreship. We will set all these parameters to 0. Side slope controls the slope of the side shell at the aft, midship and foreship. We will set foreship side slope to 0.5, midship and aftship to 0. Flare controls the curvature of the side shell at the aft, midship and foreship. We will set foreship flare to 0.6, midship and aftship we will leave 0. We don't plan to have any shear, so shear height we set to 1, which means the horizontal deck, flat deck. Fullness at the foreship we will set to 0.5 and at the aftship to 0.4. Now we will add the bulb and fine-tune the shape. Switch to the bow bulb tab and check the checkbox Create bulbous bow. Set bulb length to 3.3 meter, bulb width to 4.5, height to 4.2 meters. We see that values of the block coefficient and water plane coefficient are higher than expected, and we need to adjust some parameters. We choose to intervene on the longitudinal prismatic control parameter in the hull form. We will change it to 0.71. Thus, we have matched concept target values closely enough for this hull to be used as base for ensuing design work. Full hydrostatic initial check, compartmentation and damage hydrostatic, CFD, 3D general arrangement, preliminary structure layout, seakeeping, etc. Save settings. Now we can create a hull. Open the pull-down menu and select Create Full Model.